أهلا بكم في كايرو. This is student of third year of secondary stages. This is the second part of final revision on dynamics. Question number 1. A body of mass 10 kg is placed on a smooth plane, inclined to the horizontal with an angle of sine 3/5. A force of magnitude 8 kg dot weight directed upwards is applied to the body along the line of greatest slope. Find the magnitude of the acceleration of the motion, and if the force stops its action on the body after 3 seconds from the beginning of the motion, find the distance traveled afterwards until the body comes instantaneously to rest. Solution. From the figure, the equation of motion F equals F minus mg sine theta equals MA. 8 by 9.8 minus 10 by 9.8 by 3/5 equals 10A. Therefore, 9.8 by 2 equals 10A. Therefore, A equals 9.8 by 2 over 10 equals 1.96 meter per second square. Since V equal U plus AT, therefore V equal 0 plus 1.96 by 3, therefore V equals 5.88 meter per second. V squared equals U squared plus 2AS. 0 equals 5.88 power 2 minus 2 by 9.8 by 3/5 S. Therefore, 2 by 9.8 by 3/5 by S equals 5.88 power 2. Therefore, S equals 5.88 power 2 over 2 by 9.8 by 3/5. Therefore, S equals 2.94 meters. Question number 2. A body of mass 4 kg is projected up with velocity of 7.2 meters per second Along the line of greatest slope of a plane inclined to the horizontal at an angle of measure 30 degrees, if the resistance to the motion is 2 newtons, find the distance traveled by the body until it comes to rest. Solution. Since a change in kinetic energy equal work done, therefore half m by v squared minus u squared equals negative r plus mg sine theta by s. Therefore half by 4 by 0 minus 7.2 power 2 equals negative 2 plus 4 by 9.8 by half by s. Therefore negative 103.68 equals negative 21.6 s. Therefore s equals 103.68 over 21.6 equals 4.8 meters. Question number 3. A body of mass 4 kilogram is let descend under the action of its weight along the line of greatest slope of a smooth plane inclined to the horizontal with an angle of measure 30 degrees. Find the magnitude of the acceleration of the body if the force acting on the body upwards lies in a vertical plane passing by the line of greatest slope makes an angle of measure 60 degrees with the plane while the body continues to descend with half its previous acceleration. Find the magnitude of this force in kilogram dot weight. Solution. From the figure, mg sine 30 degrees equals ma. Therefore a equals g sine 30 equals 9.8 by half equals 4.9 meter per second squared. From the second figure, look at this second figure. M by half A equals mg sine 30 degrees minus f cosine 60 degrees. 4 by half by 4.9 equals 4 by 9.8 by half minus f by half. Therefore f equals 19.6 newtons, equal 19.6 over 9.8 equals 2 kilogram dot weight. Question number 4. A body of mass 4 kilogram is placed on the floor of a lift. Find the pressure of the body exerts on the floor of the lift when the lift is moving vertically upwards with uniform acceleration of 98 centimeters per second squared. Solution. Look at this figure. The equation of motion N minus mg equals ma, N equals m by a plus g equals 4 by 0.98 plus 9.8 equals 4 by 10.78 equals 43.12 newtons. Equals 43.12 over 9.8 equals 4.4 kilogram dot weight. Question number 5. A body is attached to the end of a spring balance suspended from the top of a lift. If the reading of the balance indicates 7 kilogram dot weight when the lift is at rest and 8 kilogram dot weight when the lift moves vertically with uniform acceleration. Find the direction and magnitude of the acceleration of the lift. Solution. From the figure, when the lift at rest therefore T equals mg, therefore m equals 7 kilogram, therefore T greater than mg. Therefore the direction of acceleration is vertically upwards. T minus mg equals ma. 8 by 9.8 minus 7 by 9.8 equals 7 by a. Therefore 9.8 equals 7 a. Therefore a equals 9.8 over 7 equals 1.4 meter per second squared. Question number 6. A man of mass 70 kilogram stands on the floor, a lift whose mass is 630 kilogram. The lift moved vertically upwards with uniform acceleration of magnitude 140 centimeters per second squared. Find in kilogram dot weight magnitude of the tension in the wire which carries the lift and the magnitude of the man's pressure on the lift floor. Solution. The total mass equal +70 630 equals 700 kilogram. Since mg minus t equals ma, therefore 700 by 9.8 minus t equals 700 by 1.4. Therefore, t equals 700 by 9.8 minus 1.4 equals 700 by 8.4 equals 5,880 newtons. Equals 5,880 over 9.8 equals 600 kilogram dot weight. The equation of motion inside the lift since mg minus r equal ma, therefore 70 by 9.8 minus r equals 70 by 1.4. Therefore r equals 70 by 9.8 minus 70 by 1.4 equals 70 by 9.8 minus 1.4 equals 588 Newton equals 60 kilogram dot weight. Question number 7. A rubber ball of mass 1 kilogram is lead to fall from a height of 4.9 meters on a horizontal solid ground and rebounds to a maximum height of 2.5 meters. Calculate the magnitude of the change of its momentum due to impact. Then find the magnitude of the reaction of the ground on the ball in Newton if the contact time with the ground is 0.1 second. Solution. On falling, V1 power 2 equals U power 2 plus 2AS. Therefore, V1 power 2 equals 0 plus 2 by 9.8 by 4.9. Therefore, V1 power 2 equals 96.04. Therefore, V1 equals square root of 96.04 equals 9.8 meter per second. On rebounding, V power 2 equal V 2 power 2 minus 2 by 9.8 by 2.5. Zero equal V2 power 2 minus 49. Therefore, V2 power 2 equals 49. Therefore, V2 equals square root of 49 equals 7 meter per second. The norm of vector H2 minus vector H1 equals norm of M by vector V2 minus M by vector V1 equals 16.8 kilogram dot weight dot meter per second. Since Ft equal M by V2 minus V1, therefore F by 0.1 equals 16.8. Therefore, F equal 168 newtons. R equals F plus mg. Therefore, R equals 168 plus 9.8 equals 177.8 newtons. Question number 8. The smooth spheres of masses 20 and 50 gram move along a horizontal straight line in two opposite directions. They collided when their velocities were 10 centimeters per second and 25 centimeters per second respectively, and they form one body which stopped after cutting a distance 35 centimeters under the action of constant resistance. Find first magnitude of their common velocity immediately after collision. Second, magnitude of the resistance in dyne. Solution. From the figure, M1 V1 plus M2 V2 equals M1 plus M2 V dash. Therefore, 20 by 10 plus 50 by negative 25 equals 20 plus 50 by V dash. Therefore, 200 minus 1250 equals 70 V dash. Therefore, negative 1050 equals 70 V dash. Therefore, V dash equals negative 1050 over 70 equals negative 15 centimeter per second. Therefore, the magnitude of the velocity of the formed body equals 15 centimeter per second. Each direction is the same direction. Of the second one. V2, V power 2 equals U power 2 plus 2AS Therefore, 0 equals 15 power 2 plus 2 by A by 35. Therefore, negative 2A by 35 equals 225. Therefore, A equals negative 225 over 2 by 35, approximately equal negative 3.2 centimeter per second squared. Negative R equal MA. Therefore, negative R approximately 70 by negative 3.2, R equal approximately 224 newtons. Question number 9. A car of mass 4 tons moves with a maximum velocity of 72 km per hour on a horizontal straight road, the resistance of which is 30 kg dead weight for every ton of the car mass. Calculate the horsepower of its engine if the car ascends a road inclined to the horizontal with an angle theta, such that sin theta equal 1/20. Find the maximum velocity of the car in km per hour if the resistance is the same on both roads. Solution. On the horizontal, F minus R equals 0 because the velocity is maximum. Therefore, F equal R Therefore, F equal 30 by 4 equals 120 kilogram dot weight. V equals 72 kilometer per hour equal 72 by 5/18 equals 20 meter per second. Power equals FV equals 120 by 20 equals 2400 kilogram dot weight dot meter per second equals 2400 over 75 equals 32 horses. On the inclined plane, from the figure, F dash equals R plus mg sin theta. Therefore, F dash equals 120 plus 4000 by 1/20 equals 320 kilogram dot weight. Power equals f dash v dash, therefore 32 by 75 equals 320 v dash, therefore v dash equals 32 by 75 over 320 equals 7.5 meter per second equals 7.5 by 18 over 5 equals 27 kilometer per hour. Question number 10. A car of mass 12 tons is moving up a road inclined to the horizontal at angle whose sine equals 1 over 100 with a maximum velocity of magnitude 54 kilometers per hour. If the car descends the same road with a maximum velocity of magnitude 90 kilometers per hour, find also the horsepower of the car engine. Solution. Moving upwards, F equals mg sin theta plus R equals 120 plus R kilogram dot weight. This is number 1. Power equal F by V equals 120 plus R by 54 by 5 over 18 kilogram dot weight dot meter per second. Moving downwards, F dash plus mg sin theta equals R, therefore F dash equals R minus 120 kilogram weight. This is number 2. Power equal F dash by V dash equals R minus 120 by 90 by 5 over 18 kilogram dot weight dot meter per second. By solving the two equations, one and two, therefore R equals 480 kilogram dot weight. Power equals 120 horses. Question number 11. A mass A of 400 gram was placed on a horizontal smooth table and was tied from the two opposite points in it by two strings. The first passing over a fixed pulley at the edge of the table and hanging from its other end. A mass B of 400 gram. The second passes over pulley at the opposite end of the table and hanging from its other end. A mass C of 200 gram, such that a mass A and the two pulley lie on the straight line perpendicular to the edge of the table, and the distance between the two pulleys is 156.8 centimeters. If the system starts moving from rest when the mass A was at the pulley near to the mass C, then the mass B was taken off after 1 second from the beginning of the motion, proves that the mass A comes to rest when it is about to collide with the other pulley. Solution. Since the mass 400 gram is greater than the mass 200 gram, therefore, the system moves in the direction of the mass 400 gram. Therefore, the equation of motion of the three masses (400 by 980 minus T1 equals 400A, and T1 minus T2 equals 400A, and T2 minus 200 by 980 equals 200A, adding, therefore 200 by 980 equals 1000A, therefore A equals 200 by 980 over 1000 equals 196 centimeter per second square. Look at this figure. After 1 second, then V equals U plus AT equals 0 plus 196 by 1. Therefore, V equals 196 centimeter per second. S equals UT plus half AT power 2 equals half by 196 by 1 equals 98 centimeters. Before taking off the mass B directly, the body A will be at a distance. The body A will be at a distance equals 156.8 minus 98 equals 58.8 centimeters. From the pulley towards the body B, from the pulley towards the body B. Therefore, the equation of the motion of the two masses for 100 gram and 200 gram after taking off the body B directly. Look at this figure. T minus 200 by 980 equals 200 A dash minus T equals 400 A dash, adding negative 200 by 980 equals 600 A dash. Therefore, A dash equals negative 200 by 980, over 600 equals negative 980 over 3 centimeter per second square. V squared equal U square plus 2A dash S. Therefore, 0 equal 196 by 196 minus 2 by 980 over 3 S. Therefore, S equal 58.8 centimeter. It means that the body A reaches to the near pole from B, then it will be about to rest. Question number 12. A body of mass 4 kg moves in straight line such that its displacement vector is given as a function of time by the relation displacement vector S equal r power 2 plus 3t in the direction of unit vector E, where E is a unit constant vector, S is measured in meters, T in seconds. Find the kinetic energy of the body in joules after 3 seconds from the beginning of motion. Solution. The displacement vector S equals T power 2 plus 3t in the direction of unit vector E. Therefore, vector V equals d dt for the displacement vector S equals d dt for t power 2 plus 3t in the direction of unit vector E. Therefore, vector V equals 2t plus 3 in the direction of unit vector E. V equals 2t plus 3. V when t equal 3 equals 2 by 3 plus 3 equals 9 centimeter per second. The kinetic energy equals half mv power 2 equals half by 4 by 81 equals 162 joules. Question number 13. Smooth sphere of mass 1/5 kilogram moving in a straight line with velocity 9 meter per second on a smooth horizontal plane collides with another smooth sphere of mass 2/5 kilogram at rest if the two spheres form one body after impact. Find the common velocity just after impact. Number 2, the loss in the kinetic energy in joules due to the impact. Solution. From the figure, M1 V1 plus M2 V2 equals M1 plus M2 by V dash. M1 equal 1/5, V1 equals 9 plus M2 equals 2/5, V2 equals 0 equals M1 equal 1/5 plus M2 equal 2/5 by V dash. Therefore 9/5 equals 3/5 V dash. Therefore V dash equals 3 meter per second. The lost kinetic energy equals half M1 V1 power 2 plus half M2 V2 power 2 minus half by M1 plus M2 by V dash power 2 equals half by 1/5 by 81 plus 0 minus half by 3/5 by 9 equal 8.1 minus 2.7 equal 5.4 joules. This is the lost kinetic energy equal 5.4 joules. Dear student, we finished the second part of final revision on dynamics. Until we meet again, goodbye.